Okay, this is the presentation about the Abinsula web platform developed thanks to the collaboration with Agris, because as you know, most of the data, the total data in the platform are coming from this pilot, and they help us to elaborate the platform in a way to be more more relevant for researchers in particular. The objective of the platform is to provide something that could collect as much as possible information from the farm in real time. So integrating different type of inputs from environmental to production to individual data and information. And at the end of it, to create some alerts related to the welfare issues or also related to environmental condition or also to production. These activities face some issues, in particular related to the lack of standard of the equipment in the animal management. So the equipment we try to interface are all of them are proceeding with different strategies, different type of output. There is no standard, so it's need to have an ad hoc approach for each farm. In that way, also other issues are related to the company that currently has some application that are disinclined to the openness and apply some vendor lock-in strategy. So if you want to move from one company to other, you risk to lose your previous data collected. So first of all, I want to start from the area where the data were collected, and basically is in Bonassai that you have visited last year, and the area is basic two indoor areas, so the production milking area and the experimental sheepfold with the milking machine, and we managed also to consider an external area that is close to that area, but is a simplified grazing area, taking as example for the grazing area. These are the equipment and devices integrated in this study. So I want to show to you that each of them are, of course, a different type of measure collected. Each of them has different frequency of collection, and each of them has different data collection strategies. And most of them, highlighted in red, are not easily able to connect to external platform. In case of weather station, because they has also buy for the project, they are considered was considered to buy the devices with open API that are application programming interface useful for integration of the data. So the idea is to collect all this information in only one platform for the farm, basic on the IoT strategy. I don't want to bore you with this slide, but it's just to give you an overview of the difficulties to collect all this information, because some of them are collected manually, other are created, the devices create some reports in CSV, Excel file, and other are maybe collecting data and transfer to external platform, but not open. So we try to find a strategy to collect all of them in the same place, and give also at the end also the opportunity to have open API to extend this process to other platforms needed in the future. Here, just an example of that integration regarding the weather station, for example, as you can see in the bottom part, and also in the upper part, the data coming from the milk production, so regarding the individual milk meters and the milk tank reading. We create two phases of the same platform because we want to divide the production hair and the experimental hair data. So in the upper part, the blue one is related to the production data with different definition of group, and below the experimental one. This is an example of what we can collect in terms of data related to single animal. So as you can see, sorry for some Italian word here, but as you can see, there are information related to the production of milk, information related to the weight, to the body score and that score, information of the feeding, so the time in the pasture, and also the feeding given by the farmer. So this is each sheep has its own screen with its own data. So we can manage to have a single a specific alert for each of them. Regarding the alert, we implemented two types of them, two types of modality. So the first one is the most simple, is based on the threshold, on the value, and time value. So if the values go beyond it, an alert occurs. And the other type is more dynamic because it's related to the previous data collected. And this has been applied in particular to the weight and to the milk production. So in case, for example, a sheep will have a high degrees of production of milk in the 48 hours after, an alert occur to alert the farm that something could happen. Here below, there is also an example of the static threshold that we have related to the THI. So the calculation is runtime, so thanks to the meteo station installed. And in that case, if the data go beyond the threshold, an alert will arrive to the farmer. Here other examples. So we can provide information when the temperature in the stable or in the pasture becomes too high. The milk production drop too easily for an individual animal, and also information in case of the weight drop of the animal. The way to explain this alert in the platform are thanks to a table that we can see on the right. So it gives the level of gravity of what happened, and the other alert could be sent automatically by email, providing some information about the alert itself. Here is just a list of what we implemented in HiGRIS pilot, because the measure collected in that area. So we can have alerts on temperature indoor, thanks to the sensor installed, and for the outdoor we can have temperature, rain, THI, and WCI, that is another index related to the wind and cold stress, and alert related to the production of milk and static weight. Now I want to go to the platform just to have a rapid overview of it. So give me 1 second to... Okay. Okay, this is the dashboard related to the production health. So if you can see on the left the subsection related to each device. So starting from indoor and outdoor weather station. On the central part, we have just a map to visualize the farm. 3 subsections related to the alerts, and then on the right we have a group view of the animal and the individual view of each animal. So starting from the weather station, this is what we have to see what happened in the past, recorded by the sensor installed within the barn, so regarding the temperature, humidity, and CO2. The weather station has some more information also related to the rain and wind intensity and direction. We have a screen from the milking production. So each animal has its own production, and we collect different measurement values and time to collect this data, this milk. Milk tank information, so recorded by the tank. Weight, weight and score, so data collected from the weight, the scale, and information collected manually by the operators regarding the body condition score and DAG score. And we have created also, we try to create a different way to collect information related to the feed. So basically the farmer write on the paper what they have give to the herd. So we try to create a sort of form to facilitate it in order to get that data on the platform directly. It's something that should be look into the deep, maybe to be easier. And yes, information regarding the DCC. Regarding the environmental part, we have connected. We propose here information regarding the weather station, indoor and outdoor, and also some information related to the forecast. Here below you can have information regarding the temperature, and is not included right now in the platform, but could be an idea to have an alert of what can happen the next week. So in terms, for example, of THI or temperature, could be very useful. Regarding the animal alert, this is very similar to what you've seen before from the slide from German. Here we propose a dashboard for researchers. So here the researcher can modify the different threshold in terms of percentage of variation of weight, for example, or production loss in terms of milk. And here below there is the table that save all the alert registered. Okay. Sorry. Okay. Okay, stop functionality. And yes. Okay, more or less that's all. That's all here. Okay. Thank you.
Thanks, Francesco. Gerardo is now going to talk to us about the THIcare app.
Okay. Well, first of all, you skip the first one. Okay. Well, first of all, I want to stress that this was a work in which we interacted with people from companies, basically farmers, people from the university, and also people from the industry. Because to build up an APP is not our competence in the university, but at the same time, we did to the companies the clear ideas that we interpret from the farmers. And this is the idea. It's the name of myself, El Hadi from Barcelona. Raúl González, you know, is from the area of Castilla-León, and also Francisco Prieto, which is here, that he was so nice to come also here for the discussion. Well, first of all, why we are putting the sheep in shelters? You know, but some people sometimes forgot that we have very harsh environments with high requirements in some periods or some productions. We have extreme weather conditions, like now in Spain, for example, or in Greece. And also we have predation. Now in the north of Spain, we have wolves, and this is making more important to protect the animals inside of the buildings. Well, the problem that arrives is the shelter conditions are not easy to manage, because in some cases they are old buildings, but especially because the farmers are not all the day there. They are only in the working hours, and they have a concern if they let the open the windows or not, just to avoid robatories, etc. Well, also we agree very early in our project that the welfare issues were very important also. They were basically a flock level, but with enormous, huge impact on the individual animals. And of course, according to this, we need an answer to have a tool, cheap, easy to understand for farmers, user-friendly, and this was the idea to develop an APP with our telephones. We did previously a review of all the works in the literature. We agreed to use, because this is a big confusion also between us, we agreed to have an only equation to use for THI. And also we decided to specify the environmental indicators of stress are related with the thermal discomfort, the air quality, and also the bedding quality, as was explaining before, because this is also, the animals are just staying there. Of course, we need for each of them thresholds, and especially for the early warning systems. With this, we implemented a cheap weather station, but with the big advantage that the weather station cost is approximately 300 euros. But the big advantage of this is that we can also implement different external sensors that we put inside of the farms. All of them are communicating between them with Bluetooth, very efficient Bluetooth, but also we communicate with the system using the Wi-Fi. And this is the way that we receive the data and we are able to decide actions. We put in the farm, just you can see in the wall, this is in a metal box, one of the temperature and relative humidity sensors. We put inside of plastic containers that we protected inside of these concrete pieces, just to have the communication of the external humidity with the internal. These are normally used for irrigation, and they work with capacitance. And this is the result. We have a lot of data, as Francesco was presenting, and we know from dairy cows that this can with thresholds can be transformed in like traffic lights indicators. The idea here is black is dead animals, and in the middle we have purple, red, yellow, orange, etc., green, blue, and dark blue or light blue. With this, we are indicating if the animal is comfortable or discomfortable. And you can see that in green is between, this is for dairy sheep, basically between 52 or 50 and 65, basically. Well, we know that, and we have the animal-based indicators from other projects indicating us which is the things to be taken into account. We have the thermal discomfort, the air quality, the bedding quality, and also we have the feeding indicators, the amount of food, etc., etc. We communicate with the cloud using the EcoWit platform, which is an open and free platform. And with this, the idea is to develop the thresholds for each of them. That means we will have a lot of colors for each of one indicators. And with all of this, we want to ask the platform and communicate to our telephones or our computers in a clear signal that can be interpreted by farmers. Well, this was the idea of the THIcare app, which is free and is a product able for all people. And it's very nice because it's produced in Apple and Google systems. And also I'm putting here one user that you can use and also one password, but we prepared it just for all the people like a demo. And you can just now go and you will see one farm, which is the experimental farm of the UAB. And it's nice because these days are very hot. And well, I checked it just now before coming here, and the data today is mild because it's only orange, but yesterday was red. You will see. And the other nice thing that we decided to put is in English, in Spanish, in all the Catalan, Euskera from Basque Country, and Galician language, but also French, Greek, Italian, Norway, and Romanian. No, that means currently we have all available immediately to be used. Here is, for example, myself as user. I'm going there, I'm putting in English. I have some description of the project and giving thanks to the European Commission for their help. And also we have some approaches, which is, for example, decide to receive messages or not with the alarms. We can modify the levels of alarm, but of course, in the automatic system is fixed for some thresholds. This is the current situation. We are very happy with 31 farms of the project, and we know that some more from Romania and some more from Greece are joining. That means we have a wide representation of the European situation. For in blue is dairy sheep, in yellow is fattening farms, in green is meat flocks, and in purple is the goats. Well, and I will show you, this is only touching, all the only instrument that we need to go in. This is the case of Barcelona in one day with outside temperature is the big one, the 57, inside of the farm. And this is the THI, the first line. The second, which are like clouds, is the quality of the air. It was yellow in Barcelona, in the university, and also is the bedding system. We facilitate the localization for all people because we include an image of the farm. That means you can ask where is exactly this 45 placed. And also, well, I want to show you some different cases because, for example, with 70, we have inside of the farm yellow. That means it was normal, I agree, but the values are greater. That is announcing me that the farm is not losing the heat load. But you will see that I ask just clicking on the 70, and I can put during one period, 1 year. I have the possibility to extend to 1 year, the mean, the minimum, and the maximum. I have also the same for each area on the farm. That means we have a map of heat in all the farms. And also, for example, in this case, I can ask what happened there. And it was one water through that was leaking, and it produced an increase of water that until now we are not able to reduce. Well, this was in winter, this was in the middle season of spring, but of course we started to see, I removed the farms, but you can see in some cases outside is mild, but inside is hot, and in special place is very hot. And this is the situation in the last days. And you can see this is Barcelona, the university, red and purple. That means our sheep are cooking or something like that because they are really very happy. But no, very hot, not very happy. Okay, and what I want to show you. The interesting thing is that we are treating with the data. We have, for example, the correlation between the indoor on the Y, X, and outdoor for the X. Well, you can see that the line, the dots, are over the line. That means the farms are, I will say, warmer than outside. This is medium, or average. This is for minimum. During winter, they are working fine. But what happened in the summer? And the surprise, because it's new for me, after 1 week, we can discriminate between farms. Farms red that are hot, they are not decreasing in temperature. There are others in blue, which are in the middle, but there are someone that are very fresh. They are not achieving with high outside, high inside. And this is probably the interesting thing that we need to select. And well, I want to show you what happened, because this is Barcelona Experimental Farm. It was the day in which I was reading there, but look, if I'm taking like a zoom in this sheep, you can see that they are panting. That means after 80, when they are red, this is the reason of the alarm, they are more than 120 breaths per minute. That means I counted exactly, there was 136. That means we need to develop a device to calculate this. And probably we can do this with cameras. Well, in any case, going to finish, the THIcare is an already available PLF tool for immediate use, no cost. It was paid by the project, with 2 operating systems and 9 languages. Easy to adapt to other livestock species. To make this for cattle, I only need to change the early warning system values and the colors. It's compatible with different commercial types of weather station. We have a list of compatible low-cost devices with peripheric sensors and free-access climatic platforms. It's possible to have an scalable architecture. That means today I buy the station, tomorrow I will put air quality, the day after tomorrow I will put the soil. No problem, it's very easy to implement. It's user-friendly. We have the comments from the farmer, and it's very intuitive. We try not to put words, just images, and it was well accepted. It was, for me, the best prize of the THI. But in any case, it was so funny that our friend Ludovic presented in Romania and also in Moldavia, and we won 2 gold medals. Thank you, Ludovic, because we never expected this. Thank you very much. Well, this is Spain, no? And you say the technology, how the sheep are using the technology. They are shedding by the technology. Okay, this is all. Thank you very much.
That's brilliant. Thank you, Gerardo. Any questions? You have stunned everyone to happiness. Gerardo, oh, apart from German. Oh, we've got another one. Good. Jermaine first. Go. Sorry. Oh, no.
Hi. Great presentation, great work. One question about the sensor stations. Do you have a commercial accord that they give you open data, or you need to go to the website and download it and the app do it automatically?
No, I'm happy for this question because it's a key question, and also happy because the engineer is there. Well, our proposal was to use a free platform. This was the reason we looked for different ones, and we decided to go Frogit, which is a company, compatible with others, it's not a problem, but they construct their own platform, which is in the web. The name is EcoWit, but you can use also Weather Underground, which is another one of different company. But they are nice, probably because they want to sell equipments, and they are offering you free all the data. The things that Francisco did, and if not correct me, is to adapt all our, all the platform available in our APP. But really, they constructed an API to interroga the platform, and it put in the telephones, in 2 languages, the device. Thank you. I did well. Thank you, Francisco.
Yeah, thank you, Gerardo. I have a question. When you presented when you summarized the data per shed, per farm, did you look also at the difference between night and day?
No, now, but it's very important. I agree with you. We expect that normally in nature, the animals will resist the hot hours of the day, but during the night it will cope with the problems and compensate. For example, eating, for example, doing other things, drinking water, etc., etc. But the data that we have now is, the data that I presented is only on the mean of the maximum, of the mean of the minimum, or the mean of the means. No? Okay? But in any case, we have all the data, and with the help of the informaticians and data engineers, we will solve this.
There is a comment, more than a question, from Jan Ledoux. She says that very useful to be able to expand to other livestock types, especially young cattle. Do you agree?
Yeah, I agree. I have a previous data to transform, but it's one thing that Francisco already prepared it, and we are expecting, because the idea is we will stay working during 1 year approximately. This is the thing that we paid with the project to him. But after the project, we are talking with the university to license the use of the EPP to some company. And we are thinking about different possibilities, but we are open, totally open.
Okay. If that's us finished questions, so I'd just like to finish off by saying thank you to both of our speakers. Thank you very much.